Hey everyone, I wanted to go over some of these practice problems on the practice test. So let's start with number 2. Number 1, I know we did in class, everybody should have. All rectangles are not similar. But number 2 wants to know, are these two triangles similar? And that's what this symbol means right here, is similar. Now remember, they're not congruent. Congruent means they're exactly the same size legs and the same angles. Similar means they have all of the same angles, but their legs could be different. But even if their sides are different lengths, they're still going to be proportional. So what you're trying to figure out is if I take 6 and find some number to multiply it by that equals 9, and then I multiply that same number times this 9, it should be equal to 15 if they are similar, because the side lengths should be proportional. The corresponding side lengths should be proportional. So in reality, what we're looking for is 6 divided by 9, the same as, is 6 divided by 9, that's the green ones, and let's change this. The same as is 6 divided by 9, the same as 9 divided by 15. Are those two things going to give you the same answer? So let's do 9 divided by 15. So the question is, are they? Let's pull up the calculadora. Okay, so is 6 divided by 9. So 6 divided by 9 is 0.66666, which should be 2/3, right? Let's see, we can use the calculator. 2/3. Is that the same as 9? Not 999. Divided by 15. That's 0.6. 0.6 is just the same as 3/5. So 3/5 and 2/3 are not the same thing, right? So that is not the same. So these two are not similar. They are not similar shapes because their sides are not proportional. Remember, you have to justify everything on the test. So this is one way to do that. Are not proportional. Okay? So we're kind of asking the same thing in B, right? Is triangle RAM similar, there's that symbol again, similar to YAK. So RAM is this triangle, so is this little triangle similar to YAK, Y-A-K? And this comes from those similarity rules on page 120, those theorems. And what it's going to be is like, so A is the exact same angle, okay? So they share angle A. Now, what else do we know? Well, these markings, we know that they gave us some markings, so this probably wasn't just for fun. These markings mean this side is parallel to this side. Since those lines are parallel, we know that angle Y here and angle R are the same. We also know that angle M and angle K are the same, but we only needed to know one of those sets, not the same together. These two are different measure. But as long as two triangles have at least two angles in common, we know the third one has to be the same. So even though they're different sizes, and even though we don't know the side lengths, we can say because of the angle-angle theorem of similarity on page 120, okay, we know that these two angles are, or that these two triangles are similar, not congruent, but similar, okay? What else? Okay, question 3. So the important part of question 3 is that we are dilating the shape based from the origin. So that's really important. The origin here, if this is our y-axis, right? And this is our x-axis. And then we know that the origin is right here at 0, 0. Okay, so we can tell that the first point here of that toe of this shoe, it looks like a shoe to me, I don't know what it looks like to you guys, is 1, 1. And since we're dilating it from the origin, we can just multiply those points. We're going to have a new point at, it's going to be 3 times bigger. 1 times 3 is 3, 1 times 3 is 3. So we're going to have a new point at 3, 3. So let's see, let's do this in a blue. So we're going to have this new point here is going to be at 1, 2, 3, 1, 2, 3 here. Okay. And let's say, so that was that point. That was, this point is now here. Let's do another one. Let's do this point here, which is 1, 2, 3 up 1. 3, 1 is going to be at 9, 3. We multiply both coordinates at 9, 3. So 3, 4, 5, 6, 7, 8, 9, and up. Oops, that doesn't need to be a point there. 9, and then up 1. It was already up 1, 2, 3, right? So we already have a new line here. This here is going to be this corresponding line to this one right here. It's going to be 3 times bigger. It's this one right here. Okay, so I don't want to like waste time and go through this whole problem, but you just take the original points and you multiply them by 3 and you get your new coordinate points on this side. Okay, let's see, let's keep going. True or false, number 4. Are these two triangles congruent? Well, I don't know any side lengths, so I can't figure that out, but they share this angle 38, right? But the other angle is different, right? 73 and 68 is different. But in order to prove that they're not similar, we still have to find that third angle, right? So we know all of the angles of a triangle add up to each other. So 38 for this first triangle ABC, 38 plus 68 plus some number we don't know, angle A, the measure of angle A is going to equal 180. So if we subtract from 180, 68, and then we subtract 38, okay, we will get the other angle. So where's my calculator? So 180 minus 38, and then minus 68, and we get 74. So angle A is going to be 74 degrees. So I can already tell just by doing that much that they are not similar because I already know that this angle's different than this angle. So they are not going to have all the same angles because this is 73 and 38. So this other angle must be 74 and 60, 69. This must be 69 degrees. Okay, so they do not have all the same angles. So this is a big false. All right, let's keep going. How about number 4 or number 5? Calculate the x value there. So because this angle is congruent to that angle and this angle is congruent to this angle, by the theorem of angle-angle similarity, these two triangles are similar. If they're similar, I know for a fact that their side legs are proportional. So I know the corresponding side lengths. I know that this side length, 7, is corresponding to this side length. And I know the side length, this side 4, corresponds to this side length. And then I know that the side length of 8 corresponds to the side length of x. So I know that side length 4 right here times some number is 7, or that 4 over 7, this 4 over the 7, this proportion, or this ratio is equal to, it makes this proportion, 4 over 7 should be equal to 8 over x. Okay, so you can solve this by cross multiplying. 4 times x is 4x equals 7 times 8 is 56. Divide both sides by 4. X equals, let's see, 4 can go into 5 one times, 14. Okay. You could also have done it as, so x equals 14. You could also have tried to have figured out what is 4 divided by 7. Okay. And if you did that, you figure out 4 divided by 7 is 0.57. Oh, that's not actually what I wanted to do. I wanted to do 7 divided by 4, you guys. I'm sorry. 7 divided by 4, you could figure that out as 1.75. What that means is 4 times 1.75 equals 7. So now I can take 8 times 1.75, which was meant, now this is my scale factor, 1.75, and 8 times 1.75 is also 14. So 2 ways to get the same answer. Looks like I have just enough time on this video to do the answer to question 6. And you're going to need your theorems from page 120 and from beyond. So what we need to do here, are these two triangles similar? Is triangle ABE similar to triangle EDC? Right? And we're going to want to use those theorems of similarity. What do we know? We know because of the vertical angle theorem that this angle is the same as this angle. And do we know that these sides are proportional? So what's 8 divided by 4 is 2, right? And 10 divided by 5 is also 2, so they are proportional. So because of the side angle side theorem of similarity, these two triangles are similar. Okay, but you have to have that proof. You have to have that justification. So don't forget to use these to prove your answers. Okay?